Level up your listening with Bose Quiet Comfort Ultra earbuds and headphones with immersive sound and world-class noise cancellation for a not-so-silent night. Visit Bose.com/Spotify to shop sound that's more than a present.
Wells Fargo presents one of the surest ways to grow your money. A Wells Fargo CD account, where you can earn a 5.00% annual percentage yield on an 11-month term with a minimum opening deposit of $5,000. Visit a Wells Fargo branch or wellsfargo.com/CD rates to open a CD account and start growing your savings with us.
Wells Fargo Bank, N.A., member FDIC.
This is SpaceTime, Series 23, Episode 87, for broadcast on the 26th of August, 2020. Coming up on SpaceTime, a new record asteroid close encounter for planet Earth, the ultimate RAVE dataset released, and Ariane 5 launches a second satellite mission extension vehicle to keep spacecraft in orbit longer. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Planet Earth's just had another close encounter with an asteroid, this one the size of a small truck. The near-Earth asteroid 2020 GQ swooped just 2,950 kilometres above the southern Indian Ocean. Travelling at around 12.3 kilometres per second, 2020 GQ was first detected 6 hours after its close encounter. The 6-metre-wide space rock, tiny by asteroid standards, was one of several similar events which occur each year. The asteroid was first noticed as a long streak in a wide-field camera image taken by the Zwicky Transient Facility. The director of the Center for Near-Earth Object Studies, Paul Chodas from NASA's Jet Propulsion Laboratory in Pasadena, California, says estimates suggest there are literally hundreds of millions of small asteroids the size of 2020 QG. But they're extremely hard to find until they get very close to the Earth. Like 2020 QG, the vast majority pass by, usually at much greater distances. But what makes this one especially exciting for scientists is that it's entered the record books as the closest known non-impacting asteroid. Evidence of just how close it got is dramatically displayed in its asteroid trajectory, with Earth's gravity swinging it by some 45 degrees as it swooped by the planet. The European Space Agency's Near-Earth Objects Coordination Centre says there are currently 23,160 near-Earth asteroids and 110 comets, whose orbits all bring them close to the Earth. And these include some 1,485 objects discovered since the beginning of this year alone. This is SpaceTime. Still to come, the ultimate RAVE dataset released. And Ariane 5 launches a second satellite mission extension vehicle designed to keep spacecraft in orbit longer. All that and more still to come on SpaceTime. Well, some have called it the ultimate RAVE, the release of the sixth and final dataset from the RAdial Velocity Experiment, or RAVE, the largest systematic spectroscopic survey of the motions of stars in the Milky Way galaxy. The massive project has surveyed a representative sample of the stellar population in our neighbourhood, covering a volume of space roughly 15,000 light-years across. The collaboration has now published the results for over 500,000 stellar observations, measuring velocities, temperatures, compositions and distances. This unique dataset enabled scientists to systematically disentangle the structure and evolutionary history of our galaxy. RAVE observed the sky for almost every clear night for a decade between 2003 and 2013, using the UK Schmidt telescope at the Siding Spring Observatory in far western New South Wales. It utilised a specially built fibre optical setup to simultaneously take spectra from up to 150 stars in a single observation. RAVE surveyed the stars of the Southern Hemisphere, getting a representative census of the movements and compositions of some 451,783 stars. In all, a total of 518,387 spectroscopic readings were taken, breaking the light from these stars down into elemental spectral lines, providing details on the composition, the temperature, the surface gravity, and the radial velocity or movement of each individual star. Massive multiplexing operation was the largest spectroscopic survey ever undertaken at that time. Now, by comparison, the previous record surveyed was just 14,000 targets. This final RAVE data release not only provides for the first time the spectra of all stars in the RAVE sample, the stars were also cross-matched with stars from the second data release catalogue of the European Space Agency's Gaia mission. RAVE collaboration leader Matthias Steinmetz from the Leipzig Institute for Astrophysics in Potsdam, Germany, says the RAVE data releases have provided new insights into the motion of stars and the chemical structure of the Milky Way. The 15-year project has been one of the first systematic spectroscopic galactic archaeology surveys, providing new insights into the structure and composition of our galaxy. The survey has confirmed that dark matter, an invisible component of the universe made of as yet unknown material, dominates the mass of our galaxy. RAVE's also discovered that the Milky Way's disk is asymmetric, and it wobbles owing to the interaction of the spiral arms with the infalling of satellite galaxies. RAVE also allowed for the identification of stellar streams in the solar environment. These streams of stars are the ancient remains of satellite dwarf galaxies, torn apart and cannibalized by the Milky Way in the past. The chemical element abundances of the observed stars also hold important clues about the chemical composition and the subsequent metal enrichment of the interstellar medium, as traced by stars of different ages and metallicities. All elements other than hydrogen and helium are considered metals by astronomers. And these metals were all produced by earlier generations of stars, either during their lifetimes or in their death throes. So with RAVE, astronomers are searching for some of the very first stars in the universe. These are metal poor and give clues about the earliest epochs of stellar evolution and formation, and therefore the chemical evolution of the Milky Way. To find out more, Andrew Dunkley is speaking with one of the pioneers of the RAVE project, Professor Fred Watson.
Fred, you're pretty close to this one.
Indeed, yeah. I wasn't actually the project scientist. That was the role of one of my colleagues in the University of Ljubljana in Slovenia. His name is Tomáš Svita. My job was to be the project manager. So RAVE was actually quite a large consortium of something like 60 scientists from 20 institutions internationally, many of them located in Europe. In fact, it was led by Professor Dr. Matthias Steinmetz, who is head of astrophysics at the Leibniz Institute for Astrophysics in Potsdam in Germany. So Matthias, Tomáš, and myself were the three, what you might call managers of this project, but there was also a board, an executive board, which we're all members of, and then the consortium itself, as I said, 60 scientists. So what is it? It is a project which had its inception back in 2003. I remember a meeting on a chilly morning in Cambridge, UK, where we discussed the possibility of using the United Kingdom Schmidt telescope at Siding Spring Observatory here in Australia, and was equipped then with a robotic fiber optics machine called 60F, that stands for 6-degree field, the field of view of the telescope, which would allow you to gather information on the velocities of stars, accurate velocities for stars. And this proposal was actually on the back of a spacecraft that was being planned. I think it might have been FAME, the spacecraft that was being proposed by the German Space Agency. And the idea was that the spacecraft would make measurements of the velocities of these stars across the line of sight, and we would then from the ground do the equivalent but along the line of sight. And if you can combine those, you get what's called the true velocity of the star. So the whole idea of this RAdial Velocity Experiment, and radial velocity is just the velocity of a star along the line of sight, was to build a database of stars using the Schmidt telescope. And indeed, it got kicked off. It went through all kinds of tribulations in its early days, but it started pilot observations in 2003. In 2005, the RAVE project became the only project that the UK Schmidt telescope was undertaking. So it was undertaking it throughout the whole year rather than just on selected dates each month. And the project grew. So it actually grew in many ways. You know, the initial idea was to gather velocities of stars. And I might just add, got a vested interest in this, but I'm not boasting about it from any personal point of view. But we did great things, there's no doubt. When we started, the total sum of stellar star radial velocities was about 20,000 that had been gathered for the previous 150 years. And within the first year, we had, I think, more than doubled that. We'd gone to 40 or 50,000. I can't actually remember the number. But it became quite obvious that this was a very effective way of improving our knowledge of the velocities, the motions of stars in the sun's neighborhood in our galaxy. And that's why the project then kind of took off. And basically, we observed for around about 10 years. It was the final observations were made by somebody called Fred Watson, and I think it was the 4th of April 2013. It was in the wake of the Wombalong fire that nearly took out the observatory. I think I did 4 nights of observations in the April of that year just to prove that it wasn't the fire that brought the project to an end. In fact, we essentially ran out of funding. However, in that 10 years, we measured 518,387 spectra, that means the data points, for 451,783 stars. There you go. That's the final number. So the observation stopped in 2013. 7 years later, what is happening is the final catalogue of all these data has been released. That was when we released what's called DR6, the 6th data release of the RAVE catalogue. And it's the sort of final product. This is the end product of what the survey has been all about. And I'll shut up for a minute so you can ask a question. But when I start again, I might just give you some hints into what has been discovered from that.
Well, that was going to be my question, because you've done all this work over such a long period of time, and I'm sure that you've been able to crunch the data and come up with some revelations. And I'm just looking at some of the information that's been released, and they're talking about things like how fast a star has to be moving to escape gravitational pull. But I'm quite intrigued by the results confirming that dark matter dominates the mass of our galaxy. I mean, it's something we don't know much about, but you've been able to confirm that it is a dominant force in the universe.
Yeah, that's right. And certainly in our own galaxy. So what you're doing is you're using the speeds of stars to essentially reveal something about the gravitational field in which they're moving. That's basically how you it's one of the ways that you can tell what sort of gravitational pull stars are feeling. And sure enough, we get this same result, that most of the mass of our galaxy is in dark matter. That other result you mentioned, it plays into the same idea, in fact, because the idea of determining the minimum speed needed for a star to escape the gravitational pull of the Milky Way, it's actually one of the first papers that was produced from RAVE back in about 2004. Very early result. What's called the escape velocity of the galaxy. That gives you a mass of the galaxy. But of course, that mass includes not just the stars you can see, but also the dark matter. And in more detail, RAVE has shown that the disk of our Milky Way is wobbling slightly because of the satellite galaxies, like the 2 Magellanic Clouds. The way they are interacting with our galaxy, it sort of has wobbles in it. And we've also found streams of stars which are probably the remnants of dwarf galaxies that have been pulled apart. The first one that was found, it's probably back in about 2006 or thereabouts, was something called the Aquarius stream. It was the dawning of the stream of Aquarius that was the title of the paper, I think. So that's dwarf galaxies that have been ripped apart. They have merged with the Milky Way, but we still see their evidence in the movement of the stars. So it was a pretty neat project, I have to say. And let me say that I am very honoured to have played a part in it. My role was essentially supervising all the observations. It was a team of half a dozen of us who did the observing. I was managing that group as the astronomer in charge of the observatory, but also as the RAVE project manager. I spent a lot of time worrying about budgets and where money was coming from. I spent a lot of time worrying about the fact that the fibers in our fiber optic machine kept breaking and all sorts of stuff. It's why, Andrew, I've got no hair left virtually, that RAVE put a big load on my shoulders. but honestly, it was worth every lost hair of it, because well over 100 top-class scientific articles have come from the RAVE project, and that's just a brilliant output. So it's kind of RIP RAVE, because this sixth data release really represents the end of the project, and the fact that those data are now public. Any of our listeners could go and access them. You've got to go and find them at the Institute for Astrophysics in Potsdam on their website, but it's pretty easy to do if you just Google RAVE, and it'll take you straight there, or to some party or other that might have the same name.
And I suppose, Fred, with all the information you've collated and released, it may well pave the way for future studies, and we may, through other avenues, learn a heck of a lot more about stars and maybe even dark matter.
In fact, those studies are already underway, Andrew. You're quite right. Yeah, so a similar survey, but in a little bit more detail, because it's a bigger telescope, that's going on with the Anglo-Australian telescope, the 3.9-metre telescope at Siding Spring. That's called GALAR. GALAR is Galactic Archaeology with Hermes, and Hermes is another of these fibre optic spectrographs, but working in a different way. But the one thing that really has, I think, sort of shone the way ahead and actually has allowed RAVE data to be used in a completely new way, that is the Gaia spacecraft. Gaia is an ESA spacecraft which is measuring the positions of stars with micro-arc-second accuracy, and you can combine the data coming from that with the RAVE data to get really extraordinary detail on the way things are operating in our galaxy, not just the movement of stars in the galaxy, but their chemistry, their temperatures, surface gravities, all of that stuff comes from this combined set of data. So it's really a really powerful tool.
And you also, as a part of it, tried to find some of the very, very first stars. I mean, that must have been interesting and difficult, I imagine.
It is. It's exciting stuff as well. So what you're looking for is stars that have got a very low metal content in their atmospheres, principally iron. The lower the amount of iron there is in the atmosphere of a star, the earlier it must have been born in the history of the universe, because iron is enriched gradually throughout the history of the universe. So RAVE had the potential to find those. In fact, I think a couple of times stars found with RAVE were record holders for the earliest known star. That's a movable feast. It's like the most distant known object. It's something that keeps changing as new technology comes along. But yes, it pointed to very early stars, clues about the earliest epochs of star formation and the chemical evolution in the Milky Way.
And that's Dr. Fred Watson, an astronomer with the Department of Science, speaking with Andrew Dunkley on our sister program, Space Nuts. And this is Space Time. I'm Stuart Gary. Still to come, Arianespace has launched another satellite mission extension vehicle designed to increase the orbital lifespan of existing spacecraft. And later in the science report, a new world record high temperature set in Death Valley. All that and more still to come on Space Time. Arianespace has launched the new mission extension vehicle and 2 new telecommunications satellites into orbit aboard an Ariane 5 rocket. Arianespace Flight VA523 blasted off from the European Space Agency's Kourou spaceport in French Guiana.
À tous les DDO, attention pour les décomptes finales. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top. Image Vulcain, image UAP, décollage. La propulsion est nominale.
And we are off. Galaxy 30, Mission Extension Vehicle 2 and BSAT 4B have started their journey. He's telling us that the trajectory is normal. And we've broken the sound barrier, Damien.
Exactly. We are now traveling faster than the speed of sound, which is equal roughly to 1,200 km per hour, and the speed will continue to increase in the coming seconds.
Ariane 5 is blazing a trail across the night skies at the Guiana Space Center, heading out over the Atlantic. Everything's going according to plan. Right now, we are using the boosters to get us away from the gravity of our Earth, aren't we? They're doing all the work.
Yes, they are doing most of the job because they provide roughly 90% of the thrust today. It is equivalent to 13 jet engines for each boosters, and their job is really to push us away from ground and to provide sufficient velocity to the launcher. And we need a lot of energy to do that. Each booster burns 2 tons of propellant per second.
That's an awful lot. He's telling us that everything's going normally. We are now losing the boosters. They have done their job. They've burnt their propellant. We don't need them anymore. The lighter we are, the faster we go. The top of the vehicle, that section containing those satellites, we call it the fairing. What's its job?
Its job is to protect the satellites from the outer world, first at liftoff, because the liftoff generates a lot of noise, so it protects the satellite from this noise. And during the atmospheric flight, it protects the satellite from the friction with the atmosphere, which we call the aerothermal flux.
Our altitude, we're 100 kilometers above our planet. That means we've crossed the border with space, often known as the Kármán line. Getting closer now to being able to eject our fairing, because we don't need it anymore, Damien. We're in space.
Exactly. The effect of the atmosphere is now very low.
The 3,298-kilogram Intelsat Galaxy 30 was released 27 minutes after launch, followed 7 minutes later by the 2,875-kilogram Intelsat Mission Extension Vehicle MEV-2. MEV-2 will be used for in-orbit satellite servicing, docking with and extending the life of existing geostationary telecommunications satellites. 13 minutes after its deployment, the 3,530-kilogram BSat-4B telecommunications satellite was also released into its geostationary transfer orbit. This mission's also tested several new technical modifications to the Ariane 5 launch vehicle. These include an onboard autonomous tracking kit called CASIV, a new vented nose cone design, and new materials for a lighter upper stage and vehicle equipment bay. The vehicle equipment bay is the launch vehicle's brains, housing all its computer systems and avionics. These modifications will continue to be fitted to all the remaining Ariane 5 flights, and they'll also be incorporated as standard equipment on the new Ariane 6, Ariane 5's replacement, when it comes into service either at the end of this year or early next. This flight was the 109th mission for the Ariane 5 launch vehicle. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with a science report. What could be the highest temperature ever reliably recorded on Earth may just have been reached in California's Death Valley. Weather stations at the aptly named Furnace Creek have reached a record 54.4 degrees Celsius. That's 130 Fahrenheit on the old scale. The record, which is still being verified by the US National Weather Service, comes amid a blistering heat wave baking the US West Coast. The previous record, 54 degrees Celsius even, was also recorded in Death Valley. That was back in 2013. Mind you, it's not the only record. A higher reading of 56.6 degrees was recorded in Death Valley 100 years ago, but that remains disputed. And another record temperature of 55 degrees Celsius was recorded in Tunisia back in 1931, but it also lacks scientific credibility. So for now at least, it looks like 54.4 degrees Celsius is planet Earth's new record. Now, speaking of records, a new study has shown that global atmospheric methane levels are at a record high. The findings, reported in the journal Nature, show methane emissions have risen by nearly 10% over the past 2 decades, resulting in record high levels of the powerful greenhouse gas. Atmospheric concentrations of the gas, at 1,875 parts per billion last year, are now more than 2.5 times above pre-industrial levels. The authors found the emissions were mostly driven by agriculture and the natural gas industry. Increasing consumption of red meat saw a 12% increase in emissions in agriculture alone in 2017. That's a direct result of bovine flatulence. A new study has warned that e-cigarettes are acting as a gateway drug encouraging regular cigarette smoking. The new findings, reported in the Drug and Alcohol Review, are based on a study of more than 5,000 women born between 1989 and 1995. Scientists found that 12.7% of those who had never smoked before, but had used e-cigarettes, went on to take up regular smoking. That compares to just 3.2% who took up smoking without first having tried vaping. And women who were depressed, who drank heavily and had troubled childhoods were the most likely to take up smoking after first trying e-cigarettes. The findings support several previous studies which have found that kids who smoke cigarettes often began by vaping first. Fossils of a new species of theropod dinosaur have been discovered on the Isle of Wight. The ancient carnivore named Vector reovenator inopenatus dates back to the Cretaceous period 115 million years ago. A report in the journal Papers in Paleontology say the fossils suggest this newly discovered individual was around 4 metres or just over 13 feet long. The fossilised bones from the neck, back and tail were uncovered over a period of several weeks from 3 separate sites along the Knockcliff foreshore. And that's the show for now. SpaceTime is broadcast on Science Zone Radio by the National Science Foundation in Washington, D.C., and through both iHeartRadio and on TuneIn Radio. Or you can subscribe and download SpaceTime as a free podcast through Apple, Stitcher, Bytes.com, Pocket Casts, SoundCloud, Spotify, YouTube, Audio Boom, Podbeam, Android, Castbox, from spacetimewithstuartgary.com, or from your favorite download podcast provider. You can help support the show and the work we do by visiting the SpaceTime online shop and grabbing yourself a few goodies, or by becoming a SpaceTime patron, which gives you access to commercial-free double-episode versions of the show, as well as bonus audio content and other rewards. Just go to our Patreon page through spacetimewithstuartgary.com for all the details. If you want more SpaceTime, check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, at SpaceTime with Stuart Gary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to www.facebook.com/spacetime with Stuart Gary. SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.